Okay, here we go. Classic triangle within a triangle question. I think that the easiest way to solve this type of question, whenever you have a triangle with a triangle, is to draw the two triangles side by side. So this is the small one, ABE, and this is the whole one, ACD. Because then it's easy to compare the lengths on the two triangles. So we know that AEB has a length here of 6, this big one has a length here of 10, this length is 5.1. Now, we need to work out the length of DE. If I label these to make it more easy to see what's going on, this is triangle ABE, so that's the small one here. And then the big one, ACD, is the one I've written next to it. So it's fairly obvious from drawing the two next to each other, the scale factor is what you multiply 6 by to get 10. If you divide 10 by 6, you get 1 2/3. So the scale factor is 1 2/3, which means that if I multiply 5.1 by 1 2/3, I'm going to get the missing length here. One 2/3 comes from dividing 10 over 6, you get 1.666 in the calculator. If you multiply 5.1 by 10 or 50 divided by 6, we end up with 8.5. Now, careful. Scale factor is 10 over 6, 1 2/3. That means that AD equals 5.1 times 1 2/3, which is 8.5. But we need to work out DE. And so if the whole length here is 8.5, and this bit is 5.1, then it follows that DE is what's left over. So DE is going to be 8.5 minus 5.1, which is 3.4. It then asks you for the area of ABC as a proportion of the area of the trapezium BCDE. Now this is quite a difficult question. And here's how I would solve it. The trapezium BCDE is what's left over when you subtract the area of the big triangle from the little one. So we need to do the big triangle minus the little one to get the area of this trapezium. And if we need to work this out, is it possible to work out the area of these triangles? Well, it's actually kind of tricky. We don't have a lot of information about the triangles. What we need to do is work out the relative sizes of the triangles. And we know that the scale factor is 1 2/3, which means that the lengths on the small triangle get to the big triangle. You multiply by 1 2/3. That's the scale factor. Which means that the area factor, the ratio of the area, is going to be 1 2/3 squared, which is going to be 25 over 9, or 2 7/9. So this triangle, if the area of this is 1, the area of this is 2 7/9. Now it's all about relative amounts. If I call the area of the small one, that's the best way to explain this. Okay. In relative terms, if the area of this one is 1, the area of this would be 2 7/9, and it's just relative areas. So that means that the trapezium, the difference between them would be 2 7/9 minus 1. So the area of the trapezium would be 1 7/9. So if we're looking at the ratio of the area of the triangle to the triangle ABE, which is the small triangle, the area of the trapezium, which is the difference between the big and the triangle and the small triangle, it's going to be a ratio of 1 to 1 7/9. So if we do 1 divided by 1 7/9, we're going to end up with 9/16, which comes out as a decimal value of 0.5625.